amplitude and the, you know, the displacement and everything related to that. Now, let's talk about the somehow or another the longitudinal wave, the same thing, no difference at all. When you say longitudinal wave, the same thing, longitudinal wave, same thing applicable to that as well. Same wavelength, but here there are few definition you need to know. Now, what are those? In case of transfer waves, you have crest or trough, right? In case of longitudinal wave, the wave particles are compressing and expanding. So where they compress, we call that compression. And where they expand, we call them rarefaction. So here, what is compression? What is compression? The region in the longitudinal wave where particle of the medium are closed to each other is called as compression. And rarefaction, where the particle of the medium are far away from each other. In that case, what is wavelength? A bit different, right? Distance between two consecutive compressions or rarefactions. Other than that, all the definition is same. It's a frequency, time period, everything is same, no difference at all, right? Everything is 101% the same, no difference at all. But the basic, the difference will be there anyways. So the displacement in that case will be from one consecutive, from the mean position, which is the center somewhere here, to one of the point is called as amplitude will be the maximum displacement from the mean position. In that case, the mean position is somewhere in the middle, right? And displacement is for any point, for any particular wave, right? So this is what the point is. Now let's draw some differences between longitudinal wave and transfer waves. So what is transfer waves? Longitudinal wave. The first difference is a definition. Particle travel perpendicular to the direction of the motion of the wave. Here, particle travel parallel to the direction of the motion of the wave. This is the first difference, right? Now, what is the second? The second difference is the example of that, or if you want to draw a diagram that will help you out. In that case, the diagram will look like this. In here, the diagram will be like this. You can see here the second example. For transfer waves, light waves are like that. In that case, you can have sound waves produced in the spring, and so on. Next is, in transfer waves, crest or troughs are formed. In that case, compression or rarefactions are. Next difference is, here the distance between two consecutive So distance between two consecutive compressions and rarefactions, right? There is a formula we have it, V is equal to frequency lambda. That is a relationship between speed of the wave, frequency of the wave, and wavelength, which is represented by lambda. For example, if frequency is given as then what is the velocity or speed of the wave? It will be 50 multiplied by 10, which is equal to 500 meters per second. Right. Now, wave behavior when you're talking about. Now, remember that wave actually exhibit some properties so that we say that it's a wave. Number one is reflection. Refraction is diffraction. Now, what are these? One more. In case of reflection, it's just like that something that strike the wall will come back. So in this case, if there is a medium here, for example, wave just go strike the boundary of a medium and comes back into the same medium. So property of the wave to just reflect and come back into the same medium is called as reflection. We will study that reflection in more detail in section of light. Okay, for the time being, just remember that reflection means just the wave reflect back into the same medium. And what is meant by refraction? In case of refraction, same thing, when light strikes the boundary of a medium, like that. So rather it you can see through the window. The room is considered to be a different medium and outside is considered to be a different medium. So light just go from room to the outside and so that you will be able to see the objects, the outside. So in that case, the speed, of course, changes and the wavelength also changes. We will do that in more detail. Now, this is very interesting. To make you understand what diffraction is all about, we created a sort of a small slit means a small opening. Okay. And we consider wave as parallel lines which are equally distant from each other. Right. The distance is called as the wavelength, considered as lambda, which is wavelength. This is what we called as a wave front. When the wave front just passes through this small opening, it spreads out. So spreading out of the wave through the small aperture opening is called as diffraction. Right? So what does mean by diffraction? Is spreading out of the wave through the small opening is called as diffraction. Now let's see an example of this. There are two cases, you can see that. The parallel distance between the lines is basically considered as a wavelength, right? Now, if that distance is, you can simply say that distance is smaller than the wavelength, or you can say wavelength is greater than this gap, there will be more spreading. But if the wavelength is smaller than, very much smaller than the gap between them, then you can see there will be less and less spreading out. It looked like a straight line. If the distance is keep increasing, the spreading will be more or less will be reduced. Okay, so if the distance keep on increasing, the spreading will be as less as it can be. Now you can see another very good example which is shown here. In the water, if you placed some sort of, object there, you can see that if the water is passing through there, so it will show you the edges. You can see the wave spread out to fill the gap behind the object. So it starts spreading from the point where the object is. See that, right? Okay. So the extent of the diffraction also depends upon the wavelength of the wave. Now it depends also if the wavelength is shorter, right? The greater the wavelength, the greater is a diffraction. Check it out. If the wavelength is shorter, the diffraction is a shorter, smaller. While if the gap is more, the diffraction is more. There will be more spreading out of the wave here. So it depends. What is a gap there? What is a wave there? What is a wavelength there? So this is what we called as diffraction. Small wavelength, small diffraction if you place the object. Long wavelength, long gap, long diffraction. Okay. So in this chapter, we have seen few formulas. V is equal to frequency lambda. Then we have seen F is equal to 1 upon T. frequency is equal to 1 upon t. We have seen refraction, refraction, diffraction, the behaviors, right? And we do see transfer wave, longitudinal wave, mechanical wave, and all that. So this lecture is completed. In the next lecture, we will continue with some of the details related to the waves, and also we also see electromagnetic spectrum, and some more details will be coming up shortly in the next lecture number 18. So it's nice to talk to you, and hope to see you in the next lecture. And if you really want to get further knowledge and further details along with the past paper and everything, I want you to join with our Mixit tutors and live classes. So we will do the past papers, each and everything along with that. Thank you very much. Hope to see you soon, and thanks for watching my video. Bye. Take care.